Hi, this is an introductory video looking at the Grasshopper plugin for Rhino 3D, and this is a visual programming language that allows you to interact with your kind of recipe for creating an object or a form or a calculation using and adjusting parameters to end up with different results. So this is on screen. We've got what we call a definition. Other people might call this an algorithm, and this is basically a set of instructions that runs from the left across to the right, and along the way we add components that do things, that add things, that change things, that interrogate things, and we end up with a form. So this one is using a component called Voronoi 3D to create this kind of form. Okay, but it needs some information for it to be able to do that. It needs to have basically a cube populated with points that it can then create cells from, and which we can then weed out extra lines that are there and then create a kind of a skeletal type of form that is basically our model. So it's not until we get to this particular point that we actually output this and it goes back to Rhino. So I'll just kind of explain what's happening here, and because this is what we'll be producing. Okay, so we start off by plotting a rectangle, and the sides of the rectangle, these are governed by this slider, and as you can see here, the same numbers going into each one, so that's going to generate a square. Okay, we then want to create a box from that square, and we're using the same height, so we get a cube. Okay, so at this point we do have a model, we have a cube. Okay, this component then scatters points inside that cube in a random fashion. Okay, we can choose the number of points, and we can set a seed value which kind of changes the randomness. It's called pseudo-random number, really. Okay, those points are the input for the Voronoi 3D. Okay, and it creates a cell around each one. So a bit difficult to imagine, but imagine there's a point here, a point there, a point here, a point here, and the component here then plots the distance between each point and halves that, and looks at all points in 3D space and creates a 3D cell around it. It'll be easier to understand this once we get the component on screen. Okay, then what we want to do is extract just the edges of these cells so that we can turn them into these kind of limbs appearance. So that's what this allows us to do. This breaks up the cells, and we're extracting the edges. The letter E stands for edge. Okay, there's a lot of edges because the cells touch each other, so they meet at an edge. So with this setup, there's 138 edges. Okay, but actually there's only 74 unique ones. So this component weeds out the duplicate lines, the duplicate edges, and then only those edges go along to this component called multi-pipe, and this basically adds a kind of a tube onto each one. But where it meets other lines, other edges, it creates a kind of an elbow or a knuckle or a knee type joint. Okay, this little routine up here, this is just to show you how you can select an individual item from a list. So here it's saying choose line number 44. So the whole list goes in, but only line number 44 is highlighted, and you may want to do something special with that, and off it goes on its own route. Okay, so the idea of this one is really just to introduce the software and get you able to input these components, input the number sliders, and control the visibility as well. Notice these are generally grey, fairly dull grey. Some of these are pale grey. Okay, so these have had their preview switched off. So we'll come to all these when we encounter them in the tutorial. Okay, so we want to get back to Rhino now. So let's try and get out of this view. I'm stuck in a let's Alt F4. Let's get away from that. Thank you. Stuck in a PDF. Don't want that to happen. So this tutorial is getting done in Rhino 8. Okay, because we'll be moving to this software as of autumn 2024. Okay, so you'll find Grasshopper on the standard toolbar near the end. It's a green icon. It's supposed to be a grasshopper kind of looking through a hole. Okay, so let's launch that. Now, because my machine has had different versions of Rhino and Grasshopper on, the software has automatically picked up quite a number of plugins that I've already used. So I'm just going to maximize the Grasshopper view for a second, and in a standard installation the tabs would stop at Kangaroo 2. Kangaroo is a kind of physics engine within Grasshopper. All the names after that, these ones from Pufferfish onwards, these are plugins that I've added. This panel here is also a plugin called Open Nest, and this item here is a plugin called Bifocals, which I advise you to use if you don't use anything else. Use Bifocals. Okay, so before we do anything with Grasshopper, let's get the screen set up properly. So if you've just got a single VDU, then you need to use half and half. Okay, if you've got two screens, it's ideal. You can just drag this onto the second screen. Okay, but with just a single screen, you really need to see a kind of a 50-50 split. So you need to deal with Rhino first. Okay, so we reduce it, and let's just move this out of the way a second. And we want this to be about half the screen. Okay, there's a bit of slack here in the layers list that we don't need to see for a while. So let's give ourselves as much space, visual space in Rhino as we can. Okay, and generally we'd probably be okay with just a single viewport. Usually that's the perspective one, but we'll leave it like that just now. And then Grasshopper can take up what's left. Okay, so watch you don't go too near the top, sometimes it collapses. Okay, so we'll do that. Okay, because whatever you're doing here previews in Rhino, so you do need to see Rhino all the time. Okay, sometimes we feed objects into Grasshopper from Rhino, so in this particular example we don't, but in other ones you will see that happen. Okay, a little bit of setting up here now. Okay, if you go to the display drop down, we want to draw icons. Display again, we want to draw fancy wires. Okay, now not in this example, but in later ones we may need to adjust the preview plane size. I think I'm just going to do that just now, and if you go for 3 and enter. Okay, so it should remember that. Let's just check. Display preview plane size 3. Okay. Okay, now you could as well add draw full names. Okay, now if we use this, then you won't be able to follow necessarily the PDFs quite so easily because it will look different, but I'm going to leave that switched off, but it can be used. Now, Bifocals allows you to see the icon on the component, but also the name of it above, and that's why it's kind of like using two methods of vision at the same time. Okay, there's another one you might have just seen there, sunglasses. This is another plugin which does a similar thing. Okay, why these aren't built into the software I'm not too sure, because they're extremely useful. Okay, another thing to change here is go to View and Obscure Components. so it just fills out the panels a bit more. Okay, so let's kick off. So the first proper component on the PDF is to create a rectangle. Okay, so if you don't know where the commands are, which generally I don't, I basically use this method you're about to see to get to most of my commands. Okay, the rectangle is a curve shape, so it's likely to be somewhere on here. But again, it can be quite daunting trying to find things. So they introduced a method of just basically typing part of the name. So if you double click and start typing rec, short for rectangle, you'll see that there's two that are completely called just rectangle. Okay, the one with the black hexagonal shape, that's a holder. So if we'd drawn a rectangle in Rhino and we wanted to use it in Grasshopper, this is what we would use. Okay, if we want to create one from scratch in Grasshopper, we would use this one. Okay, so these, if you consider them as containers or holders, and this one is the actual kind of doing component. So just click on that. Okay, now our sunglasses, our bifocals, were on the parameters ribbon. So this one's easy to see, it's kind of up front. Just click and drag and pull that on. And that's what should happen. It should give you the name of the component plus the being able to see the icon so that you can follow tutorials. Okay, when an icon, when a component has a jagged edge like this, it means it doesn't contribute anything further onwards. It's just a kind of this is the end of the road for this. Okay, so these are the inputs that we have, and I did mention draw full names, so if you do want to know what they represent, you can click that on. Okay, but you'll quickly pick up what they are, so I'm going to switch these off and just tell you what they are as we go. Okay, so hovering over them tells you what they are as well. So you hover over each letter, you can see. Okay, so this has created a rectangle. There is a tiny shape appeared down here. Let's zoom in, and we can see it there. So the more solid shape is the rectangle. The grid is the plane. So here it's saying use the world XY orientation to create the plane. Okay, the X sizes go from -1 to 1, so that's -1, 1. The Y sizes -2 to +2, so that's -2, that's +2. Okay, and lastly, it's saying do you want to use a radius for the corners. That's set to 0, which means there'll be square corners. Okay, we'll keep it square. Okay, but we want to have a rectangle that's bigger than that. So we need to put sizes into here. Now, there's kind of 3 ways you could put a size into here. Okay, if I right click it, I could kind of configure the domain here. So if I wanted this to be 20 units in this direction, I would have to set a domain which was 0 to 20. 0 to 20, commit changes. So do you see how it's stretched in that direction? Problem with that is I can't see it unless I hover over the X. I can't see that value. Okay, so let's just undo that. It's not undoing, so I'm going to clear value on that. Okay, so I probably shouldn't have declared all the values there, to be honest, but anyway, what we're going to use instead is this panel. So this gives you a visual on the number that you're going to use. So if we double click, type 20, click outside, okay, you can resize that, and then connect that to both of these. Okay, so you drag from the dimple on the output to the dimple on the input. Okay, so you can see there we've got 20 reinstated that way, and if we go this way, we've got 20 going that way. Okay, that is what we'd call a constant. We can't change that without double clicking and changing the number. So if I clicked in there and said 10, click OK, the square shrinks. Okay, still that's not very interactive. So we only use those when we definitely aren't going to change the number. Okay, so let's just delete that. So you just click on it and press delete. Okay, this goes orange, saying I'm needing values, I'm needing some numbers. Okay, so what we generally would use is a slider for the numbers. Okay, so when you want to set up a slider, you just double click and you type in the range of numbers that you want. Okay, so if I type in 0, ... 20, oh, that's bigger. So the handout's saying 0, ... 100. So that's going to create a slider that goes from 0 to 100, but with no decimal places. So this will be whole numbers. So press enter. Okay, you can also do that using the less than symbol. Gives you the same slider. Okay, so if we connect that to X instead, okay, we've got a value. So this has gone grey, which means it's functioning. Okay, when you click on it and it's functioning, it goes green, so that you can identify the shape in here. So if we drag this now, you can see it's extending our shape. Okay, Y has still got its initial value. Okay, but it couldn't create the rectangle without an X value as well. So if we put that in both, we then have a parametric square, because we can control it using this parameter, so it becomes parametrically controlled. Okay, if you wanted to change the way that slider behaves, you would double click at this end of it, and this gives you the setup for the slider. At the moment we're on whole numbers, which are also called integers. Okay, if we wanted decimals, we need to go to real numbers. Okay, that's the number of decimal places. Okay, if we want just even numbers, we can select E. If we want just odd numbers, I can select O. Okay, but ours was set to integers. Okay, if we want to change the range or the maximum, you double click in here and put in a different value. Okay, if you want to change the name of the slider, which you can, at the moment it's just picked up the name from the Y input, we could say square size, say. Because we're using the same number for each one, it's going to generate a square each time. So square size, okay. Expression, that is an equation. So if we wanted whatever value comes out of here to be doubled or tripled or halved or square rooted, you can put the expression in here, and it will then do that before it puts the number into here. So let's just test that. If we put, let's say, x divided by 2, click OK, see what happens. The number gets adjusted accordingly. Okay, let's delete the expression, don't want an expression on that, and OK. Okay, there's other ways of dealing with sliders, but we'll sort that out later. Okay, so what you can do, if we want to move things, we can grab them all and just slide them around. You know, you've got a lot of freedom to arrange things. So that's our first bit of our thing. So if we move this here, because we're going to use this number again, so we want to show the wire coming out of here into the next component, which is box rectangle. Okay, so if you start typing box, and we want the rectangle one, so there it is, box rectangle. Now if you want to know where something comes from for further study or looking for other components that are like this, if you do Control Alt and click, it shows you where that's come from. Okay, Control Alt and click. Okay, if you want to copy a component, just Control C, Control V. Okay, there is another method. Shift Alt click and drag. Shift Alt click and drag. Okay, that duplicates as well. Okay, I think that's enough on the copying. Okay, so here we've got an input that needs a rectangle. So we can connect from here to here. Okay, how do you disconnect? Okay, if you right click the letter R there, disconnect from the rectangle. You can do it the other way around. Right click, disconnect the box. Okay, another way is to hold Control and click and drag back to where the wire comes from. That disconnects it. Okay, let's plug it in. If you want to move that connection to another one, it's Shift and Control at the same time, and that moves the wire. Okay, you can have more than one wire going into the same connector, but you need to hold Shift for that to happen. Okay, if I want to move both of those, I can do. They come together, so it's Shift and Control. Okay, that's gone bright red, saying, hey, you cannot do this. Okay, it's saying I can't accept a rectangle and a length value at the same time. So if I hover here, you see here, it gives you a clue as to what's happening, saying the data conversion failed from number to rectangle. Okay, so here all we need to do is disconnect the length. So disconnect the L connection, and this one's happy. We've now got a cube. Okay, now we don't need to see this component now. So as we move from left to right, we start to thin out things. We don't need to leave everything switched on. Okay, the default is for any geometry to be shown, okay, unless the preview is switched off. So if I right click the icon, I can switch off the preview. Okay, so it's still functioning, but it's not previewing. Okay, if I right click and disable this, then the box isn't going to receive its input. That stops working as well. Okay, so right click, enable. Okay, if we have both of them previewed, now there is another option once things get a bit more complicated. This one's quite useful. Okay, so it's like, oh, where's everything gone? What this means is that only the one you click previews. Okay, you can hold Shift and add others into that, but generally I kind of use this for kind of doing demonstrations really, or kind of debugging, looking for problems. Okay, so this one's usually the standard, and I would have this one preview switched off. Okay, so the height of the cube at the moment happens to be the same as the number we have here. Okay, that's not necessarily so. So if we change this, you notice the height's not changing. So if we want to have a cube all the time, this needs to connect as well. Okay, so now our cube is completely parametric. Okay, and in our example we want a value of 20. If you're struggling to get the slider to go to a specific number, if you just double click it and type in the value you want, 20. Okay, looking good so far. So Next component is to scatter dots randomly inside this cube space. So the component is called populate, and we're going to use the 3D version, populate 3D. Okay, so you can see it's already doing something. It's got a few parameters set up just so you can see that it's working, really. Okay, here it's looking for a shape, a region, so you do find a bit of terminology changes, but it's asking for the shape that we want to use. So that's an easy connection. So we've got quite a lot of dots in there. That's the number, the count, so it's got 100 points in there. Okay, S is the seed, that's the randomness. Okay, and P, if we had our own points that we wanted to put in there, we could supply it with those, but we're just going to we're letting it generate them itself. Okay, now we've got a slider to use next, which we've already got one. So we could use this again. So Control C, Control V, bring it over here, and we'll use that for the number. But remember, because we changed the name, it's retained the name. So if we double click here, take that away, it should pick up number, count, sorry, yes, count. Okay, you can't make these any smaller, I don't think. The sliders, oh you can, just a wee bit, not completely, a little bit. Okay, the seed is a starting number, so we don't want this to be too big. It doesn't need to go up to 100. Okay, so we could copy this one and then adjust it. So if we double click here, let's say that the maximum number is 10 and the minimum number is 1. We need to start with number 1, I think. So we've just got 1 to 10. Okay, if we connect that to seed, you should see a slightly different scattering of points. So you see it's just kind of, they're still random or pseudo-random, but we're just going from a different start point. Okay, now we don't need many points at all. We don't want to make the geometry too heavy, so could you change this to 8? If you double click, change it to 8 and tick. Okay, it doesn't look like there's many points, but even that number creates quite a complicated shape. Okay, so I mentioned, how the Voronoi works. Okay, so let's just draw a little diagram. Let's use a bit of colour. Okay, so say we've got 3 points in space. Okay, then the Voronoi looks for the midpoint for each one, between each point. Okay, so I'm drawing this as if it's 2D, but there is actually a kind of a 3D connection to this. So in reality, there'd kind of be 4 points if this was 3D. Okay, but then it creates a cell around them. So say we had a boundary shape of a triangle. Okay, it then will create a cell for each of these. Okay, and imagine doing that in 3 dimensions. It's quite a tricky thing to envisage, but that's what this 3D Voronoi is going to do. It's going to create cells that are kind of like 3D boxes, but they're not cubic in any way. Okay, so that's our little diagram. We could keep that, or we could delete that. In a later video, I'll show you how you can tidy these up. They're really clever. You can send them to Rhino, draw cleanly, and bring them back in and get really nice presentations for that. Okay, so the next component is Voronoi 3D. So we'll double click because I'm not sure where it lives. Voronoi 3D. Okay, where does that live? So remember, it was Control Alt click. So it's on meshes triangulation. That's where that one lives. And certainly I wouldn't have found that very quickly. Okay, it's got quite a distinctive icon, so that helps though. Okay, so if we join, it's looking for an input set of points. So it's points to points. Okay. Now you will notice though that it has resized our cube. Okay, it's kind of looked for an extent, it's kind of found the furthest away points and it's generated the cube based on those. I'm just going to try something here because I'm interested to see if we feed the box in here whether it resizes to our original box. Yeah, it does. That's good. That's a bit cleaner. A bit more easy to understand that it's taking on the original box size instead of fitting to the points itself. Okay, now there's going to be lots of times when you can't get the wiring cleanly, avoiding other points. Okay, now with this it's not too complex, but if we did want to see that wire come all the way around, then you can use what's called a relay. Okay, so we actually take the box to the relay and then from the relay into there, so we're able to see the route that the data is flowing in. Okay, there's another method, so let's just delete the relay and that'll take away the connection. Okay, what you can do is once you've made the connection, you can right click the letter B and the wire display could be hidden. Okay, so it's like a transmission, it's receiving a transmission from here to here. Okay, if you click on the component, it shows you where it's coming from, but that's a hidden wire. So let's just have it as normal, default. Okay, and we were using a relay. Okay, this isn't on the PDF by the way, so this is a little extra. Okay, so the box here is causing things to be a bit messy. We're seeing the box twice, so you right click, switch off that preview. We can now see these 3D cells inside a bit clearer. This doesn't take up much, it's not going to kind of confuse us too much, but we're good with this. Okay, now this is going to be quite a long video. The first one, there's a lot to introduce. What I'm interested now is knowing how many we want to get control of the edges. So we use a component called deconstruct brep. So there's a wee bit of typing on this one. Deconstruct brep. Where are you? Deconstruct brep. There we go. A brep is a boundary representation. So each of these cells is a brep, a boundary representation. Okay. What have we got coming out here? We've got cells. Oh, we've got just a list of trues here. Okay, it's saying, indicating each cell whether it's part of the original boundary, and it's saying true for that, for all of the cells. Okay, so this one's the cells we want to get control of. We've got faces, we've got edges, and we've got vertices. Okay, now can you see the list that's visible there is quite complex. We've got all these zeros in brackets separated by semicolons, then it goes zeros and a 1, zeros and a 2. Okay, these are called branches. Now this is where Grasshopper gets, I would say, kind of more complex, in that you have to kind of understand how the data is structured and how it's going to behave in the next move. So there's a bit of a hint in the wires here. So we've got a single piece of data coming in. So here we had just one box coming in, but here this generated a lot of points. So this generated a list of points, and that's why the wire has changed to a double line. Okay, coming out of here, it's still a list. Okay, but when it gets to here, it's broken into multiple branches of data, okay, because it wants to keep the edges of each cell together. So the faces for each cell, the edges for each cell, and the vertices for each cell, they all need to kind of go together as a set. So I'm going to bring on a component here called parameter viewer. Okay, and let's feed it the edges. This is what we're interested in. Okay, that's just the same as hovering over it. That just shows the same information. But if you double click this, you get a diagram of the information. Okay, so at this point we start to branch. Okay, so this is where it's going off into branches, and at the end of each branch there is a list. So if I zoom in, you can see the numbers on these. Okay, so these basically kind of correspond with what's happened to the objects as they go through the definition. Okay, and when we got to the deconstruct rep at this point, it then split it off into branches. So we're connected to the edges one. Okay, so the orange ball at the end, that is effectively the list of edges for cell 0, cell number 1, cell number 2, cell number 3, etc. Okay, now watch what happens if we remove that branching structure. Okay, and that's called flattening. So notice the line coming out here is different. It's dashed, it's double and dashed, so that indicates that there are branches of data. Okay, and the numbers are different in each one because the cells are slightly different shapes. You notice 0, which is the first one, it's got 21, but the third one, which is 0002, has only got 18 edges. And that's most likely because they're, as you can see here, there are different shapes inside. Some have got more sides on them than the others, so they're going to have more edges. So if we flatten the data, so you right click the letter E and you flatten it, we've just got one list of data now. Okay, if we double click and have a look, we've got one branch, one set of data that's got 165 items in it. Okay, let's have a look at what that looks like in kind of English. Okay, if we bring on the panel, panels are useful for inputting things, but they're especially useful for seeing what's happening coming out the way. So in English, those 165 items are a line-like curve, and it just goes all the way down to 164. So computers start counting at 0. Okay, so we've got 165 items. 0 to 164 is 165 items. Okay, now this takes a lot of time to kind of sink in, how the data flows through and the structure of data. You know, don't worry if you don't understand it just now at all. It will come. The more of this stuff you do, the more you'll understand it. So I'm just gonna delete that one, as you kind of need to show it, but you don't want to, because it really does kind of confuse things a bit. Okay, I could find out the length of the list from here by looking at the number on the last item, but we could also use a component called list length. List length. Okay, let's plug that in as well. Put a panel on the end of that so we can read the number that comes out, and it tells us the list length of the list. So we've got 165 lines, but a good few of those are duplicates. You know, if we've got 2 cells, I can just about make out 2 cells there. What we could do here is hide the Voronoi. So we switch the preview off for the Voronoi, makes it a bit clearer. So here we've got multiple cells. There's 1, 2, 3, at least 4 cells meeting along that edge. So 3 of those edges are redundant. We don't need them. So let's try and weed out the ones we don't need. So Kangaroo 2, which is built into the software, has quite a few utilities in it for doing things like that. So you can see here we've got remove duplicate lines. If you can't find that, just start typing remove and we've got duplicate lines. Okay, so we connect that. Okay, if I hover over here, you can see we're down to 81, so we've more than halved the number of lines. Okay, these numbers will vary if you change the count or if you change the seed. It will give us different values. So depends what your setting is here, how many numbers you come up with. But the process is the same. Okay, so our list length, if we want to copy that little routine, Control C, Control V, plug that in to this list, we've now got our 81, which can carry on to be given the multi-pipe treatment. Now, let's say you wanted to pick a specific one of these lines. You wanted to do something with it in particular. Okay. There are lots of components to do with lists, and they're found in the sets area. So there's loads of things you can play around with lists. So one that we use all the time is list item. So if we look for it here, list item, or double click, type list item. Okay, so let's take this list in again. Okay, and you can see one of the lines is already lit up because it's choosing line 0. Now let's use this panel and find out where our line 0 is. Okay, so line 0 is this one. It's 9.31937 millimeters long. Okay, if we want to go to a different one, that's a bit awkward. We'd have to choose a number. So this is where we put a slider on that has this many numbers at least. So we've got one that goes up to that value. We've got a 0 to 100 over here. So let's copy that and use it up here. Okay, so line 0, if we plug that in, should still be the same one. Watch carefully now. When we move this, the green line is going to different places. We can whiz around that. Line 80 should be the last one. Okay, so where is it? Line 80, where are you? Oh, I need to have this selected as well. Okay, there it is down here. So line 0, the first one was there, the last one is down here. Bit difficult to see, but now this has got wrap on it, so actually if we go to line 81, it should go back to this one. There we go. So it's continuing the numbers, it's wrapping. We'll stop at 100 here, but do you kind of understand what's happening there? That if line 81 is the same as line 0 because it's wrapped around this list. It's started the list again. It's come all the way back to here and it's going on again. So these are really useful little routines that crop up in every definition. You'll find them everywhere. Okay, last job for us is to do the multi-pipe. So if we double click multi and looking for multi-pipe, so this is what's called a sub-D command. It creates very kind of organic looking objects. Used a lot in kind of game modeling and character modeling. Not so much in hard edge stuff like architecture. You tend not to find that much sub-D modeling. Okay, so let's plug it in and see what it looks like. So the curves are coming out of here, the lines. So already we've got something that looks pretty interesting. Trouble is, we've got a bit of a glitch here. You know, the sub-D component doesn't necessarily want to work with the Voronoi component. So here we might need to adjust the seed until we get a cleaner result here. We don't need to see this component, so we can switch the preview off for that one. So we don't want to really progress with something like this happening, this glitch. Okay, it's maybe that the points are too close to each other. It's just kind of doubling back on itself somehow. So let's just adjust the seed until we get a version that doesn't have a glitch in it. So we don't need to change the number, but we will change the seed. So that one's clean, that's clean. That was our one. That one's not clean. There's a bit broken down at the bottom there. That one's definitely not clean. We've got a big slash going right the way through. So let's just go for the first one then. Just use the first instead. So it looks pretty clean. Just a quick inspection. Okay. This has got quite a lot of parameters on it. Node size being an interesting one. So this is where we kind of increase the knuckle size. It looks more skeleton if you do that. So slightly different slider though. We don't. This is a very small model. You know, from here to here is only 20 millimeters. So we don't want to put in big numbers here. So we'll put a slider in that is 0.3.00. Okay, so we're instantly adding in the decimal places. So if you double click 0.3.00. We could have done 0.00.3. It would have given us the same slider. So press enter now. So our slider is much more fine-grained. Okay, mine on the example is set to 0.64. So I'm going to type that in. So double click, type it in. Put that onto the nodes. We have got a bit of a glitch here. It might go away, and maybe I didn't see it, or it might go away if we change the strut size. So let's see what happens if we change the strut size. So we'll use the same slider but a copy of it on strut size. It's not going away. So let's see. This is good. You do need to kind of debug things as you go. So number 2 was clean. Let's stick with number 2 then. Okay. And strut size a wee bit smaller. I've got 0.41. Take, and that looks, like it's stretched, like it's kind of rubbery. Looks quite good. Okay, so we have a model. We don't need to see the lines now. Okay, so in reality at the moment we only need this one visible. So let's backtrack a bit and say this was a much bigger definition and I want to switch everything off apart from this one. If you click and drag over everything you want to switch the preview off for and use your middle mouse button instead, you can switch the preview off for multiple objects. Okay, and that works as well for disabling and enabling. Okay, now what is the fried egg? Hey, you've been dying to ask. Okay, if we right click a component, we've got bake. It's a fried egg. By the look of it, to me, it should be a cake if it's baking, or bread or something, or pie. Okay, not an egg. They go in frying pans or whatever. But what this does is it actually models the geometry. It takes this kind of virtual model and makes it into a more real model, but it's still virtual. So if you right click bake, offers you a layer to choose. to switch it on. So if you had a layer already, you might have one that you renamed to Voronoi that you want it to go onto. So let's just say layer. We'll go layer 3 because it's blue. I don't want to use layer 1 because that's red anyway. Okay, so layer 3, we want it to go onto there. There is only one object here, so we wouldn't really need to group it, but get into a habit of grouping because you can always ungroup later. It's a lot more difficult to group than it is to ungroup. So put group, yes please, very courteous, and OK. So in Rhino now, if I click and drag on that, you see we've got a model. If I try that now, there's no model there, it's just the preview from here. Okay, but this is actually a model. So, you know, if I wanted a different version of this, say I wanted 3 different versions of my Voronoi, I can just go back to the seed. Okay, let's change the seed till we get another clean one. Not good, not good, looks good. Okay, bake that one to a different layer. Let's go to layer 4, group, yes please. Okay, so that's our second Voronoi. I want another different one, so let's just have 3 of these. So looking at the seed, that one looks pretty clean. There's a bit of a glitch there. Let's see what 7's looking like. 7 was a really bad one. 8 is looking not bad. Let's go with that one. So we'll bake, right click, bake to a different layer again, group, yes please, and there's our third Voronoi, modelled in seconds. You know, instead of, you know, huge amounts of calculation and remodeling and plotting points. If we switch this preview off, we've just got our models here. Let's have a wee shade on that. Marvelous. Okay, so these could be, you could be making chairs, these could be stools or something like that. Voronoi stools. Bit small, only 20mm, so maybe big enough for a toy soldier or action man or something. But that is your first definition. Let's just tidy things up a wee bit. Let's just pull it onto to here. If you wanted to put a title on it, you can double click and start to type scribble. It's a bit kind of rude really, isn't it? But you then double click that, and this is our 3D Voronoi generator. Okay, that's the size of the text, so this is the title. Might go up to 40, maybe a bit big. Okay, but you can annotate these if you're wanting to, you know, instruct somebody else on how it works. Okay, and let's put the free previews all back on. So it's middle mouse button, preview. Okay, and remember, if we use this is useful for kind of talking through the process. So preview only the selected one. We've got a square, we have a cube, we have points distributed inside that cube. Okay, Voronoi generated from that, broken up, get rid of any lines we don't need, and finally multi-pipe it. Okay, I hope you kind of understood just the general principles of how this amazing bit of software works, and you know, hopefully you just kind of seen the potential just in that very short example. Okay, more to come. See you soon. Hi, back again. You thought you got rid of me, but small addendum to this video. Saving files is, you know, very important, and it's quite clever in Grasshopper. We haven't given this file a name, so if we save the document, I'm just going to pop it on my desktop and let's call it 3D Voronoi. Okay. Now this particular definition doesn't rely on any particular Rhino file. We didn't input anything from Rhino. Okay, so this hasn't been saved either, but that would be okay. So file, if we just went to a new file, okay, save untitled, I'll say no to that. Okay, I'll use the same template, large object millimeters. Okay, can you see that the Grasshopper just says, right, there's nothing there for me, I'll just use the same file. Okay, our baked ones, they've gone, I lost those. Okay, but that's okay. Okay, but what happens if we did use something? So let's just quickly say our initial square was going to come from Rhino instead. So let's just delete this. Okay, it causes problems down the line, but that's okay. And let's create a square in Rhino instead. Okay, so I'll put my grid snap on just to make sure it's working, and I'll go at 20,20. Okay, so to use this in here, we would have to have a container for that. So this is a curve, it's a shape. Okay, we could use geometry as well. We could just, that's a more general one. There's a geometry holder, which I can't see the wood for the trees here. Down there. Okay, but actually this is a curve. So we put a curve holder on. Okay, in Rhino, I'll just deselect that. Okay, and you would say right click this, set one curve. Okay, so that's now functioning and linking these two. You know, if we deleted that curve, this would cause a problem. Uh-oh, where's my curve? Okay, bring it back. It says, ah, you're back, I can find you. Okay, if we plug that curve in instead, okay, everything comes to life again, and we should have our Voronoi. Okay, but now this file does rely on a Rhino file. Okay, so this file, even though it's only just one square, it is still important. This needs to go with it. So file, save as. We'll give this the same name as the Grasshopper file, 3D Voronoi, even though it's just a square inside it. Okay. Okay, if we start a fresh file without the square, this is going to go into an error. So file, new, same template. This goes into error because it can't find the square. It says, where are you? Where are you? Okay, so, but if we load the 3D Voronoi G 3DM file, we're back in business. Okay, so be careful with this, because they do kind of set up links. If you're using objects from Rhino, then you have to be a wee bit more careful with the file names. Okay, if we had multiple files open in Grasshopper, you'd see them here. If I close, you notice this one, if I click here, it's got a little star next to it, meaning that it needs saved. Okay, so I'm going to leave Grasshopper open, but close Rhino. Okay, actually I'm going to save this as a different name. So this is file, save document. No, let's not save it, because otherwise I want to show you what happens when you close, but you haven't saved in Grasshopper. So if we close Rhino, if we exit Rhino, this is what happens. Grasshopper says, just before you go, last chance, you hadn't quite saved things at the end there. Okay, so you get a chance to save. Okay, usual. Do you want to update Rhino? So things should be okay if we go back to Rhino 8. Okay, open our 3D Voronoi 3DM. Okay, open Grasshopper. Okay, and our file should be on recent files, 3D Voronoi, and all looking good. Okay, it's just a wee bit of file management. It's pretty critical. You don't want to lose your work. spent a lot of time setting it up. Be careful. Cheers.